What's up, mathematicians? Justin here, and in this video we'll be looking at the straight edge and the compass. Now, before we get into looking at these tools and this unit in general, let's just take a second to think about where we are and how we got here. So we are now beginning Unit 3 in this course on geometry, or the study of space. Unit 1 was measurement, all about how we measure things, and at the end of the Unit 1 we had this question of how we can know for sure that the angle sum of a triangle is actually 180 degrees. And that led us into Unit 2, which was about logic, and we also talked a bit about axiomatic systems. So now that we have that under our belts, it's time to start building our first axiomatic system. And we're going to see if this system is powerful enough, robust enough to work up towards a proof that the angle sum of a triangle is 180 degrees. Now, this axiomatic system we're going to be looking at in this unit is based on a couple of key tools of geometry. These are tools that the ancient Greeks used as well, and were very important to the ancient Greek geometries. And they are the compass and the straight edge. So let's take a look at these tools. First of all, we have the straight edge. Now, in ancient Greek geometry, this was it was specified that this would be an unmarked straight edge when we're doing constructions. One reason why I like this particular one is it has the ruler part on the short side. It kind of reminds me that the most important thing this thing does is draw straight lines, and that the measurement of anything is the secondary purpose, actually. Although, as much as I like this one, I'll probably end up using this triangle here for the most part as a straight edge. And the purpose of the straight edge is to draw straight lines, So I'll be using this and also this at times. And then the second tool is the compass. And the compass is, here's an example of one right here. And it's a tool with a sharp point you can see here on one end, and then a like a pencil tip that you can draw circles on the other end. And you can change the change this distance between this point and the pencil point, so that way you can draw different sized circles with this device. So those are our two tools. And the first thing I always tell students to do after we introduce the tools is just to play around with them. I think the best way to get to know these tools is to play around and see what happens. And so go ahead and pause the video right now and play around. What kind of interesting designs or creations can you make using just a straight edge and a compass? Try it out. All right, welcome back. Now, I wish that I had the opportunity to see all of your beautiful constructions in action. And in fact, I would love it if you made an interesting, beautiful construction, whatever you created. I would love to see it. And so if you could, why don't you put a link to it, maybe upload it somewhere on the internet, a picture of it somewhere, and put a link to it in the comments down below. I'd love to see what you created. And every time I give this assignment to students in class, inevitably some students do this design that I'll show you right now, which is they just end up using the compass over and over to make all these circles, and then they discover this sort of pattern that even without a straight edge, by just playing around with a compass with equal sized circles, you can make this sort of flower tiling. And I've actually colored this one in to make it a bit more artistic. So this is an example of something that you can create with actually this one's just with a compass. I could draw in lines here with a straight edge, and then I'd have a bunch of hexagons that all sort of tile and fit together. So that's just one example, but there are so many cool designs you can create with a compass and a straight edge. And like I said, I'd love to see yours. Put them in the comments below. And before we finish, I want to show you a couple online tools that you can use to play around with and learn more about geometric constructions. So let's look at that. Oops, wrong one. There we go. So here's the first tool. This one is, well, I mean, the website is scienceversusmagic.net, so that's interesting. It's, if you go to the original URL, let's see, maybe I can show it to you here. You'll see it's under the title Ancient Greek Geometry. Let's play Ancient Greek Geometry. So one thing that I like about this is it has these little construction challenges. And another thing I like about it is it's pretty strict about the rules. So for example, you can't just make a circle or a line anywhere. You start with these 2 dots, or a point for that matter, which we're not going to be that strict in this unit, but it just gives you 2 dots and saying with those 2 dots you can make a line or make, you can make like a circle like this, although it only lets you make it to a certain length that's already on here. So let's go ahead and play around with these for a minute. So I'll draw a line connecting those 2 points, and we see here on the right are different construction challenges we can go for. So let's try to construct a triangle. And so, okay, maybe, it won't even let me go here, so let's just go at this length. That way we can have a circle. And okay, maybe we do another circle. And oh, actually I see a triangle right here. So we can connect that point, and voila, I have satisfied one of these challenges right here. And then you can sort of reset it and start over. One thing that we could do is make something like that, that pattern of circles that I showed you earlier. So you can see if you play around with this, just make a bunch of circles that all have the same diameter. You're going to end up with that. Oops, no, that's the wrong one. I'm going to go from here. Oh, no, I got that line in there. Oh well, you get the idea. So this is a nice website to just play around with, to learn a bit about constructions and try to accomplish some different challenges in the meantime. And I like it because, as I said, it's pretty strict about only allowing you to connect 2 intersection points that are already there. It also allows you, once you've made a line, to make it longer. So I can like extend a line like that. The other tool is called Geogebra, and this one gives you more flexibility. You can put points wherever you want them, so that's cool. And you can also put line segments wherever you want them, and you can put circles anywhere you want. So this one is definitely probably the program that you're going to want to use if you just want to make your own geometric construction on digitally instead of with a pencil and paper. So let's do the hexagon again here. And so I'll draw a circle here, and then from here I can just continue to make these intersection points. I'm going to drag them all back to that center point. And there we go. So that's my nice little flower design. And one nice thing about Geogebra also is the ability to move things around, not only the canvas, but you can drag these points. And since all these other points C, D, E, F, and G have all been defined in relation to A and B, if I move A or B, those points all get sort of automatically repositioned based on the locations of A and B and the distance between them. So you can make some pretty cool graphs and then drag around different points and see the impacts of dragging those points around. And then, if I want to make a hexagon here, I can just connect these points with the lines as follows. So something like that. Okay. So, oops, there we go. So, yeah, thank you for watching this video. This was just a quick introduction to the compass, the straight edge, and just the idea of geometric constructions. And in the next video, we're going to start looking at how we can use geometric constructions to build up our axiomatic system and prove some things. And so, yeah, hope you'll join us then, and we'll see you later.